Class. Let's try to continue the topic on the analysis of structures. And at this juncture, let's try to, of course, discuss by method of sections. Unlike the previous topic that we had by method of joints, you are going to isolate joints in here, but in this particular method of sections, we are going to, of course, cut sections of any structure for us to be able to analyze each member. This is a simple truss that is very similar actually to our example, to the example that I have given you in the analysis of structures by method of joints. Don't be confused with the drawings, the colored ones, because they are just part and parcel for us to be able to analyze the problem. What is important in this topic, one advantage of the method of sections is that you could immediately determine directly the stresses of forces in any member without passing through different joints. But when you cut a section through the entire truss, the parts cut off should not exceed 3 members. Okay? So for you to be able to understand this, as I have said more clearly, we have this sample problem. Determine the internal forces in each member of the truss shown below by method of sections. So if you will notice, class, let's focus first on the blue dotted lines, ZZ. Because class, ZZ on the left will be considered first, because of course I deem it easier to solve. You will see this in the illustration later. As we have been doing the process or the way we solve, we state the given, figure, and data shown. If ever there are important data that you should state or write, you write them all, okay, as part of the given. And we have the requirements, the internal forces in members by method of sections. So we have these members AB. If you will look at the figure, we have in here AB, AC, BC, CD, and BD. Okay? For us, class, for you to have a guide or for you to easily solve the problem, you need to know first, of course, your L, because originally what are given are only the included angle, which is 30 degrees, the height of the truss, the load P, which is 100 and acting 30 degrees horizontally on top of the truss, and we have a vertical load being carried by the truss, which is 100 kilonewtons. Okay? As I've said, class, we try to simplify things out of problems, or we need to, of course, find for whatever is necessary in solving a problem. With this problem, class, you need to know, of course, L, because if you are going to have sections, class, if you are going to analyze structures by section, you need moment arms. So these are very necessary. This one, okay? The height and the length. Solving, of course, for your L, we have tangent 30 degrees. Tangent is opposite over adjacent, which is we have had this one previously as L. So we derived 5.196 meters. 5.196 meters. So class, please try to observe that with your previous activities and exercises, I am very particular with units. Okay, so please always write down the units. If it is distance, it must be meters. If it is force, as we have been using, we have kilonewtons. And if we have moments, as we have been previously discussed, moments are in kilonewton meter, because force times distance is the data that are being multiplied. So you need, of course, to indicate that one also. So in this particular case, class, you need to solve for the reaction at A, and in doing so, you need to take moments at D. Okay, so it is written in here, summation moments at D is equal to RA times the moment arm, RA times the moment arm from here. Okay, this is the moment arm. 5.196 plus 5.196 is 10.392. Then we have 100 cosine, because we are taking the horizontal component of 100, cosine 30 degrees times the moment arm from here. Okay, and we have minus the vertical component of 100, because it is going down, it will create a counterclockwise moment based from D. So 100 minus 100 sine 30 degrees times 5.196. So this is 5.196, because this will be the direction of the vertical component of 100. Then we have 100, which is the given force, times the moment arm, which is 5.196, and it is negative because it will be acting counterclockwise. Okay, so computing this value, we have RA, the reaction at A will be 50.0 or 50 kilonewtons. Okay, and the next step will be solve for the reaction at D. Okay, since this is a hinge, it will create a horizontal and a vertical component. Okay, can you follow, class? So we need to indicate the arrowheads of these two components. Okay, so how are you going to do it? How are you going to solve for RDV? You just simply take moments at A, summation moments at A, and you will be arriving at this equation. So if you're going to take moments at A, we have RDV times, what's the moment arm? 10.392. Then minus 100, which is the cosine of the horizontal force of 100 cosine 30 degrees times 3. Okay, so okay, class, going back again to in determining of course the reaction or the components at D. So we need to take moments at A. So if you are going, class, to take moments at A, so we have RDV, which is unknown, times the moment arm 10.392 minus 100 cosine 30 degrees times 3, which is the moment arm for the horizontal component of 100, and the vertical component, which is minus 100 sine of 30 degrees times 5.196, which is the moment arm, minus 100 times 5.196. This is the external load. Okay, so going back to the equation, so we derived the RDV to be 100 kilonewtons. Okay, so next is note, to counter check, you can also use summation forces vertical is equal to 0, positive going up. So if you're going to, of course, counter check the value of RDV, since that is the unknown item, we have RDV plus RA minus 100 sine of 30 degrees minus 100, that will give you, of course, 100 kilonewtons. So it's correct. Okay, the next, we have to, of course, solve for RDH. So RDH, just simply, of course, have your common sense in here, because we have 100 kilonewton acting diagonally, and of course the effect of this load being introduced horizontally will be equal to this load. Okay, so summation forces horizontal is RDH minus P cosine 30 degrees equal to 0. So RDH is equal to P cosine 30 degrees. RDH is, what is the value of PP cosine 30 degrees? Of course, is 86.6 kilonewtons. So as a reminder, note, since the answer bore a positive answer, the assumption that RDH is directed to the RDH directed to the left is correct. Okay, so since class, all the items that, or all the values of the unknown items are already, of course, we already reflect them. We had already written them on the drawing, so for you to have a guide, so that you will not be misled. Because class, if you try to, of course, consider this structure and this blue color ZZ, which represents that this structure is cut to this. So in this particular case, we try to consider this side, and all the items that you have computed or that are included in this section will be carried in the analysis, so that you will be coming up with correct answers. Okay, don't be misguided with that. So next is isolate section ZZ. Consider the side, left or right, that you think is easier to solve. In this case, we'll consider the left side of ZZ, section ZZ. You can assume the effect or the direction of each member either going away from the joint, which means tension if you go away from the joint, if the arrowhead is assumed to be going away from the joint, or directed towards the joint if it is in compression. So note that when your final answer bear a negative sign, then your assumption is wrong. Therefore, you change the direction of the arrowhead of the member. In this example, we assume that member AB is in compression, arrowhead is towards joint A, member BC is in tension, going away from joint C, and member CD is assumed to be in tension and is going away from joint C. Always cut your section with 3 members considered. So next step is you are going to draw the FBD of the left side of the section, because that is the section that you considered. Okay, left side of section ZZ, refer to the given figure above, then consider or carry all the loads and reactions included in the section. If you will try to go back to the original figure, so ZZ is this one, so we consider this side. Okay, so as you can see, we have the 100 kilonewton, which is originally of course an external load, and the computed value of RA, which is 50 kilonewton meters, and we assume, as it has been indicated in here, AB is in compression, that's an assumption. BC, because it was cut, BC in tension, and ZD is in tension. So you carry again plus the measurement, okay, or the dimension, and we have of course the same measurement for the height, which is 3 meters. And if you will observe, dotted lines are extended to form of course this joint B. Okay, so anyway, you'll discover later on why we did this one. Okay, so we have this figure. You now take summation moments at joint A, then member BC can be solved. If you're going to take moments at joint A, so may eliminate AB will be eliminated, 50 will be eliminated, CD will be eliminated. So we have this and this, because they are actually 5.196 apart from joint A. So we have summation moments at A, as our sign convention is 0, positive clockwise moments. So BC, where is BC? BC times 5.196 minus 100 times 5.196 is equal to 0. So we have BC, simplifying further, we have 100 kilonewtons in tension. Okay, our assumption is correct because it bore a positive sign. So tension yung BC. Next is take summation moments at joint C. Then member AB can be solved. So summation moments at C, this is joint C, color red. Okay, so you take summation moments at C. Okay, going back in here, so we have RA, this refers to the figure, RA times 5.196, which is the moment, R minus AB sine 30 degrees times 5.196. So simplifying further, we have AB is equal to 100 kilonewton in compression. So we assume it as in compression. Okay, so we are correct. The next, observe that this is what I'm saying earlier. Observe that dotted lines are extended to form the imaginary joint B. So we have these dotted lines to form joint B to solve for the magnitude of member CD. So you have extended this one. Okay, so if you are going to take moments at B, you can solve for CD. Okay? Kasi BC and 100 will be eliminated because they will be passing this reference point of ours. So with AB, ma-eliminate yan. So we have RA and CD. So RA times 5.196 minus CD times 3 is equal to 0. Then simplifying further, class, CD will give us 80.6 kilonewton tension. So positive siya, and we assume that it is in tension, so correct. We are correct. Okay? So next class, next step is draw the FBD of the right side of section YY. Assume the direction of the members. Refer to the given figure above, then consider or carry all the loads and reactions included in the section. Just follow what we have done on the previous sectioning or section ZZ. Okay, so in here, you're going to consider again, class, the original figure. We have this section YY. So ito yung nakat, this one. So if you are going to consider the right section, ito lang po ang kukunin natin. So we have in here AC, which I think to be computed. BC is already computed. So what we are going to compute in this particular sectioning is BD and AC. So if you will notice, class, we have again three members, AC, BC, and BD. Okay? That were cut to form the section YY, right portion. Okay? So as I've said, class, we need to carry or include all the computed values that we have previously, of course, solved. So we have RDH, which is 86.6. We have RDH, 100 kilonewtons. Then we have the external load, which is 100 kilonewtons. Actually, if you will notice, class, at joint B, wala yung load natin na 100, yung P. Kasi naputol siya, nakat. Okay? So in here again, class, we have BC, which I think was previously computed, and AC, which we are going to compute. So 3 meters pa rin po yung height ng truss natin, and the distance in here from C to D, like just like A to C, we have 5.196 meters. Hindi po nagbago. So let's try to consider this. So I think at this point you can follow, class. Okay? So if you are going to take moments at C dito. So na-eliminate ang AC, BC, and 100. So ano po yung pwedeng ma-solve regarding this? We can solve BD. Okay? Kasi if you are going to take moments at C, BD, which will be creating the vertical component, will be considered in here. So sine, kaya sine 30 degrees, and what is the distance? Ito po, yung kwan. Actually, if you're going to draw imaginary the components of BD, pag ganito rin po yung BD natin. This is BD sine of 30 degrees, and we have also the vertical component, which is I think cosine. This is cosine, sorry. This is cosine 30 degrees, and this will be BD sine 30 degrees. So going to take moments in here, class. So yung BD cosine, the horizontal one, is eliminated. Okay? and yung vertical component na lang po ang natitira. So we have in here BD sine 30 degrees times the horizontal distance, which is 5.196, minus RdV. Ito po, kasi meron siyang moment arm from here, which is also 5.196. So simplifying further, we have BD is 200 kilonewtons. So we have a positive answer. So the assumption that BD is in compression because it is going towards the joint is correct. Compression po siya. Kaya nailagay na C dyan. Okay? So next is, we have to solve for AC. Okay? AC. Where is AC now? So this is AC. So how are we going to solve for that? So summation moments at B. If you take moments at B, BC 100 will be eliminated because they will be passing here. So with BD. So what are considered in here is the BD cosine 30 degrees. Sorry. We have RDH and RDV. So in computing for AC, this one are already eliminated. Ito. Kasi dito ka nga mag-moment, di ba? Okay? So those will be eliminated. So we have moments at B, 0 positive clockwise moments. Okay, so we have AC times 3. AC times 3 because that's the moment arm. Okay, it is clockwise positive. Ito, kasi pag ganito yung action niya, clockwise. Okay, yung AC times 3. The moment arm is 3 plus RDH plus RDH. Where is RDH? RDH, it is again clockwise, times 3, still 3 from here to here. Okay? For RDH minus RDV because this is our reference point at yung effect ng RDV is counterclockwise. So we have a negative RDV, but what is the moment arm? That is 5.196 meters. So simplifying further, we have AC is 86.6 kilonewtons. So, and it is in tension. Okay? So anyway class, that's all for the day, and after this lecture, you need to solve, of course, a problem which will be included in your module. Thank you very much.